Alright, this video is about recursive sequences and factorials. First of all, recursive sequences. Those are just simply sequences that build on the previous term. So they have to give you a beginning number because the second number depends on the first number. So here's how it's written. Okay, a sub 1 is going to be the first term in the sequence, always. They have to give you that. A sub k plus 1 means to find the next term, I take a sub 1, which was 6, and I add 2. Alright, so the directions today will say something like, find the first 4 terms of the expression if this is the expression. You know the first term is 6. Okay, so to find the next term, I take a sub k, which is the term before it. I take 6 plus 2, and what do I get? 8. To find the next term, I take the one before it, which would be 8 plus 2, and I get 10. So 8 depended on 6, 10 depends on 8. To find the fourth term in the sequence, I'm going to take that 10 and add 2, and I would get 12. And hopefully you see the pattern. I'm just adding 2 each time because that's what it says to do. It's a recursive sequence because it depends on the term before it. All right? It tells you a sub 1, and you got to work your way through the rest. Let's try another one. What if this was the first one? The first one is 81. Okay? For the next term, I'm going to take, here's my formula. It's 1/3 a sub k. That's the term prior to it. So 81 is my first term. You put that in your calculator. 81 divided by 3 is 27. So 27 goes here. For the next term, I'm going to take 1/3, and this time I'm putting in 27. Well, hopefully you know that 1/3 of 27 is 9. For the fourth term, I do 1/3 of 9. Hopefully you know that that is 3. And on and on and on you could go. But it depends. It's recursive, right? It gave you the first term, and you have to find the next term based on the formula. Let's try another one. If the first term is 2, what's the next term going to be? Well, in this case, I have to take 3 times 2 minus 1. Well, 2 minus 1 is 1 times 3 is 3. So this is my second term. To find my next term, I take a 3 times 3 minus 1. 3 minus 1 is 2. 2 times 3 is 6. To find my fourth term, I'm going to take 3 times, what was my previous term? 6 minus 1. 6 minus 1 is 5 times 3 is 15. So this is what the formula is helping me do. Take the previous term, subtract 1, then multiply by 3 to get the next term in line. Alright, factorials. Now, factorials are a fun little math thing, and all it is multiplying, going downhill until you reach 1. Okay? So here's what I mean. Example 4. Factorial of 2. Well, that just means 2 times 1, and that's just 2, right? Well, that looks easy. Okay, a factorial of 3. Well, that means 3 times 2 times 1. You count down, you're multiplying all the way. 3 times 2 is 6, times 1 is 6, so my factorial of 3 is 6. Factorial of 4 is 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24, times 1 is 24. So hopefully you get the hang of it. Now, there's a special case that if you ever see 0 factorial, that just means it's equal to 1. It doesn't equal 0 like you think it would. It always equals 1. So, okay, so you're going to be asked to reduce some factorials. Don't go type in a bunch of stuff in your calculator. Look at the patterns here first, okay? So 6 factorial means 6 times 5 times 4 times 3 times 2 times 1, right? What does 3 factorial mean? 3 times 2 times 1. Well, guess what? All of those cancel out. And really all I have to do is multiply this. 6 times 5 times 4. Well, 6 times 5 is 30 times 4 is 120. And there's my answer. Look at number 8. If you had to really multiply all that out, that would be crazy talk. But you don't. It's 36 times 35 times 34, and I could keep going, right? But that's just 34 factorial over 34 factorial. Well, those two can cancel out, and now you pick up your calculator and you figure out what is 36 times 35. And you get 1260. Okay? So make these factorials work for you. Now, number 9 looks intimidating, but you guys know the rules. You just take that first number and you always subtract 1 until you get down to 1, right? So watch what happens when I take n plus 1 factorial. I start with that first number, n plus 1. If I subtract 1, I'm left with just n, right? If I take away 1. Now what happens if I take away 1 from n? Well, it's n minus 1 factorial, right? And I could keep on going. Forget that little bump in the road. I could keep on going, but I'm looking to see that I can match it to the bottom. And now that I've subtracted 1 one time, then I subtracted 1 another time. Now these factorials match and they cancel out. So my answer is simply n times n plus 1. That's it. There's no factorial anymore. We took it out when we reduced it. Okay? Let's try another one like that. Look at this one. 4n plus 1 over 4n minus 1. Well, start with the numerator and count down. 4n plus 1. If I subtract 1, minus 1 here, it's just 4n, right? Now, from 4n, if I subtract 1, I get 4n minus 1. And I'm going to leave it there because I noticed that that's exactly what's in the denominator. Now these factorials cancel out, and what am I left with? 4n times 4n plus 1, and this is how you can leave your answer. Let's try one more like this. Remember, take the numerator and just count it down. Okay? 3n minus 2, subtract 1, 3n minus 3, 3n minus 4. Notice we're not really getting anywhere, right? But let's see what we can do. Let's try it from the denominator standpoint, okay? Let's leave our numerator just like it was, and let's count down from the bottom. So 3n was my beginning one, right? If I subtract 1, subtract 2, now the factorials match, right? So now I can cancel those out. But remember, there's a 1 out here. So my answer then is 1 over 3n times 3n minus 1. Okay, and yeah, you can leave your answer just like that. Okay, hopefully that makes sense. We'll do more examples when you get to class. Talk to you then.